again, proportion here we use for population proportion, we use capital P ni lah. Kita nak dapatkan sampling distribution for the proportion P ni. So again, concept for proportion ni is the same as the concept of probability of success in binomial experiment. Okay, kalau kamu ingat balik, binomial experiment, kita go back pada X lah ya, bukan X bar lagi. So if you have your X is binomial distributed, you have N, you have pi. Okay, parameter dia proportion of success. Okay. So we define population proportion as P, okay, P, capital P equals to X over N. Maksudnya X tu number of success, okay, X kamu number of success divide by number of trials semua tu ada berapa N kamu. Okay, kalau sample proportion, we denote as small p. Kita denote sebagai small p. So p is equals to X over N. Benda yang sama tapi dalam bentuk small letter lah ya. So P for sample proportions, small p equals to X over N. X tu maksudnya sama, number of success divided by total number of trial ataupun number of your random sample lah, your N tu. Okay. So now you want to get sampling distribution of P. Okay. So again, you want to find when we mention about sampling distribution of P, so that's mean kita perlu dapatkan dia punya mean, your expected value, EX ataupun EP in here. And then we need to get your variance. Okay, EP dan juga variance dia apa. Okay. So again, your expected value of P, so I replace with X over N. So follow the properties for expected value, we will have 1 over N EX. Okay, 1 over N EX. So EX kat sini dia akan replace dengan N pi. Okay, ya. For sampling distribution for the proportion, so this one is only apply when we have large sample. Kita ada large sample sebab asalnya populasi ni daripada binomial. Bila kita ada N greater than or equal lah, letak N greater than or equals to 30, yang biasa kamu buat, kalau soalan dia X juga, kamu buat continuity correction factor. Kamu, mungkin dalam bahasa Melayunya yang kamu belajar pembetulan keselanjaran. Okay, ada kan pembetulan keselanjaran. But you have to plus minus 0.5. Okay, ini yang kita biasa buat. Bila N yang lebih besar pada 30, the N for value N greater than 30 which is not provided in your stats table. So we need to approximate. So we approximate, we change X to normal distribution. Ini kita akan tukar kepada normal lah. Taburan normal kita. Taburan normal, you have mu sigma square. Okay, mu sigma square. Okay. So we change from binomial distribution to normal distribution, but we have to add the continuity correction factor where we have plus minus 0.5. Ini yang sebelum dulu yang kamu dah belajar again lah. Level yang selain pada degree lah ya. So ini yang kamu dah belajar plus minus 0.5. Okay, when you change to normal, that means you get mu. Okay, mu equals to N pi. Sigma square equals to N pi 1 minus pi. Let's say if you want to find probability X greater than, so that means you have either to add plus 0.5 ataupun minus 0.5. It depends on the question. Macam mana? Okay. So this one again, since your X is coming from binomial punya experiment. Okay. Binomial experiment. Bila kita compute sample proportion tu, kita punya sample proportion is just X over N. So again, we need to compute the mean of the sample proportion. So expected value of capital X over N. So it becomes 1 over N EX. 1 over N EX. So 1 over N EX kamu ni is coming from binomial. So it's coming from binomial. So that's mean your mu is N pi. So ini kita replace N pi. So cancel out N, you get pi. Okay. And then the same thing, the same procedure you compute for variance dia untuk sample proportion. So P, so ganti balik X over N. So again lah properties for variance. Kalau tak ingat ke apa ke, review balik ya. Saya tak adalah nak go back lah kamu punya metric ataupun foundation. So variance X over N, properties for variance, you have 1 over N square. Variance X. Okay, variance X now is your sigma square ni. So kita replace lah N pi 1 minus pi. Because your x is coming from binomial. Kamu kena ingat, x is coming from binomial. So n pi 1 minus pi, so cancel out n, you get this one, pi 1 minus pi over n. So we can write the sampling distribution of the proportion ni. Dia akan jadi P is normally distributed with mean pi. This is your variance pi 1 minus pi over n. Okay. So let's say the question asks what is the sampling distribution for the proportion. So that's when you have to write P is normally distributed with mean pi. Your variance is pi 1 minus pi over n. Okay. So nak buktikan cara dia macam ni. Okay, Ex over n. So properties 1 over n Ex. Ex because expected value of x is just your mu, which is your n pi. Kenapa n pi? Because your x is coming from binomial. Okay. Okay. So again, for large sample tadi yang kita mention, n greater than or equal to 30. So the sampling distribution of P will be approximately normal. So we will write down here. Normally distributed, mean pi, variance pi, 1 minus pi over n. So ini bila kita standardize. So standardize Z is equals to P minus pi, square root dia punya variance dia. Sama lah, proses sama. Kita standardizekan, we have P minus pi, square root pi, 1 minus pi over n. Okay. So again, since we have the original question is coming from binomial, so again, when we want to transform to normal distribution, we need a continuity correction factor. Okay, continuity correction factor. So it's the same process as normal approximation. Cuma normal approximation is in terms of your x. Sekarang ni kita deals dengan sampling. Okay, sampling distribution of your sample proportion, which is your P is equals to X over N. Okay, so anything here, P X over N tu, dia punya tu, in terms of percentage, macam P is equal to 30% or in terms of decimal point lah, let's say 30%, which is 0.3. Okay, so this is the continuity correction factor. Okay, continuity correction factor. So let's say, sekejap ya. Ini saya nak explain dia punya ni dulu. Formula je dulu. Nanti dia punya exercise tu mungkin next week lah kita buat. Okay. Okay, so ini in terms of your sampling. In terms of your sampling proportion punya formula. Okay. Kita go back. Let's say if you have your x binomial n pi. Okay. So you want to find ini x juga katakan now your x is binomial, katakanlah n35, your pi is 0.4. Okay, so now your n is greater than 30. So when your n is greater than 30, what we need to do is to use normal approximation. Okay, so katakan you want to find probability x greater than 4. Okay, so when you have your continuity correction factor, okay, the probability x is binomial n pi. Okay, kita nak tukar kepada n is greater than 30, so we use normal approximation. So probability x greater than 4 tu kita perlu tambah sama ada plus 0.5 ataupun minus 0.5. Okay. So when you have x greater than 4, so that's mean you want 5 and so on lah. Okay. In discrete distribution, because your x now is discrete distribution, now you want to change to normal distribution. So discrete distribution either have equality signs ataupun tak ada equality sign is important. So bila probability x greater than 4, normally what you did is you want to find more than 4. Okay. So normally kita buat, kalau kamu ingat balik lah, x greater than 4.5. Okay. So yang ni yang kamu buat dalam before this one lah. Before sampling proportion, kita akan correctkan dia plus 0.5. Otherwise, mungkin kalau X dia less than, kamu akan minus 0.5. So itu dalam continuity correction factor for binomial. Okay, kita nak change pada normal. Okay, nanti maksin bila kamu dah standardize tu, kamu compute lah mu dia apa, and pi, variance dia berapa. Okay, and then you change lah normal distribution, mu sigma square. So ini yang kamu buat sebelum ni. Okay, so it's the same thing as sampling proportion. Okay, sampling proportion, so let's say we want to find probability P equals to 0.3. Sebab dia proportion, so dia tak boleh letak dalam value P equals to 4, P equals to 5. Sebab dia sampling proportion, so mestilah between 0 and 1. Kalau dalam percentage, mesti between 0 and 100% lah. So P equals to 0.3. So again, the condition dia, your original question is coming from binomial, your sampling proportion ni. X tu asalnya daripada binomial. So when we want to transform to normal, again, we need to do continuity correction factor. Tapi continuity correction factor dia dalam sampling proportion, it will become plus minus 1 over 2n. Kalau normal approximation yang kamu dah belajar sebelum ni, is just plus minus half. Kan? Plus minus 0.5 lah. So this one plus minus tapi dia ada 1 over 2n. Ditambah n kat bawah tu. Okay. So now again, bila kita nak tukar pada normal, continuous distribution. Okay, continuous distribution, it cannot take exact value. It must take in terms of interval. Kan kita tak pernah selesaikan probability Z equals to 3. Bila kita dah standardize Z equals to 3, kita selesaikan Z less than 3, Z greater than, or Z less than equal, and Z greater than equal. So when we have exactly, we have to change. So maksudnya kat sini, when we have probability P equals to 0.3, we will have probability 0.3 minus 1 over 2n less than P. Ini saya padam Okay. Less than 0.3 plus 1 over 2n. Dia dalam bentuk interval. Macam kamu buat probability X equals to 3. Exactly 3. That one is in a discrete, in binomial. But now you want to change to normal. So you have to 3 minus 0.5 less than X. And then 3 plus 0.5. So that means X kamu sekarang dah between 2.5 and 3.5. So it's the same procedure. So when you have exactly 0.3, so you will have minus 1 over 2n and so plus 1 over 2n. So konsep dia macam ni lah. Let's say, okay, kita ada bar ni. So tengah kamu tu P. So now you have P plus 1 over 2n. The other one is P minus 1 over 2n. So if you want to find probability P equals to P, so you will have P minus 1 over 2n less than P plus 1 over 2n in terms of interval. Okay, ini yang tadi Ini yang first ni. Okay, because we have quite a number of formulas. But saya tak suruh kamu hafal formula-formula ni. You just know how to use this formula to solve. Macam mana kita nak dapatkan. Kita tak perlu hafal lah macam, okay, kalau sama dengan mesti tolak, mesti tambah, tak ada. Okay. Cuma fahamkan dia punya konsep dia. Macam mana kita dapat that kind. Sama ada nak plus 1 over 2n or minus 1 over 2n. Okay, let's say the next one Okay. Let's say now, probability P less than 0.3. Macam mana kita nak buat dia punya continuity correction factor dia? Okay, again. Okay, katakan kat sini lah bar ni nampak So again 0.3 0.3 plus 1 over 2n and then 0.3 minus 1 over 2n. Boleh kan nampak ke? Okay, 0.3 ke kanan dia tambah 1 per 2n, ke kiri minus 1 over 2n. Okay. So now P less than 0.3. So P less than 0.3 in your apa yang perlu kamu fikirkan, P less than 0.3. So that means tak termasuk dalam bar ni. Kat sini je kamu betulkan. So that means it will become probability P less than 0.3 minus 1 over 2n. Okay, probability P less than ni, kita akan betulkan continuity correction factor dia. Kita akan dapatkan probability P less than 0.3 minus 1 over 2n.